Question 19, we have a diagram with P and Q on it. Part A, describe fully the single transformation which maps P onto Q. So how on earth does P end up becoming Q over here? So in terms of the transformations that are options, it's clearly not been translated. It's not been moved because this does not look like that. It has not been reflected either. There's no place that I could draw a mirror image and these would look, reflections of one another. So the only other one, there's one other that's obvious that it's not. This is not an enlargement of that one because not only does it not look the same, it's clearly not bigger or smaller. So the only one that that's left with, and this is the trickiest one to identify, is rotation. So straight away you can identify now that there is a rotation and that will give you one of the 3 marks. The other 2 marks come from identifying what type of rotation, in terms of clockwise, anti-clockwise, and by how many degrees. And then the third one, the center of rotation. In other words, that's the point that if you marked it on the page and turned the paper around, the part that wouldn't have gone anywhere. So P going on to Q, if you look at the shape of P like so and start figuring out how you'd rotate it, there's 2 ways that it can end up like this. One of them is a 90-degree clockwise rotation, and the other one is a 270-degree anti-clockwise rotation. Now both are correct, but of course the simpler one is 90 degrees clockwise, therefore that's what I'm going to write. Of course, if you had a 180 degrees, then it wouldn't matter if it's clockwise or anti-clockwise. So rotation 90 degrees clockwise gets you 2 marks in the bag. Next part is you have to figure out what point, let me just mark this point, what point, if I had sort of drawn an L shape to connect with a corner of our shape, if I rotate that 90 degrees anti-clockwise, where does this point end up? So clearly the point I've just marked with X there does not match because this needed to be here. But effectively you would have a trial and improvement of plotting a point X, drawing an L shape like I've done there, and then going through the motions and rotating it in the same manner as the shape itself. Because not only does the shape rotate, the points, any gaps like this L shape I've created there would also rotate. Now, some of them might be quite nice like this one. It turns out that it's the origin, right? But if you don't see that, the only way of going through the motions is plot your point, draw your L shape. Typically, it doesn't matter what corner you pick, so just pick the closest one. That L shape like so is 4 and 2 in length, and then when you rotate that 90 degrees clockwise, you end up 4 high, and you end up with 2 across. More importantly, that corner matches there, which means the origin is the point of the center of rotation. So rotation 90 degrees clockwise, you can say about or you can say around the point 0, 0. You could also say origin as well, I guess, but 0, 0 would be more formal. So that's us described a rotation. Part B, reflect triangle Q in the line y equals x. So I'm going to clear a bit of space here for the following. The line y equals x is the straight line that goes through all of the points where y and x have the same coordinates. So that there is our middle line. If you turn your head so that this middle line looks vertical, looks up and down, we are reflecting this over here. And by doing so, I can first of all mark that that point is shared. This point here will end up there. And then this point here will end up there. So now that I've identified the points, of course I wouldn't write in those lines, so I'm just going to raise them very quickly and mark our points. And once you've done that, you join them up. So this line here matches that one, and then after that, I'm just going to fill in the gaps of this and this, like so. It asks us to label the new triangle R, so I'm going to do that, and that's us done.